Recording in progress.
Hey everybody, this is Dr. Jacobs. Welcome to our lecture on single case, quasi-experimental, and developmental research. Our unit learning objectives for this week, and these are the things that I want you to be able to do by the end of this whole unit, is I want you to be able to describe single case experimental designs and discuss reasons to use this design. I want you to be able to explain the one group post-test only design and describe the situations where it would be useful. I want you to be able to describe the one group pre-test, post-test design and the associated threats to internal validity that may occur, including history, maturation, testing instrument decay, and regression toward the mean. I want you to be able to compare and contrast the non-equivalent control group design and non-equivalent control group pre-test, post-test design and discuss the advantages of having a control group. I also want you to be able to distinguish between the interrupted time series design and control series design. I also want you to be able to describe cross-sectional, longitudinal, and sequential research designs, including the advantages and disadvantages of each. Okay. I also want you to be able to explain what a cohort effect is. All right, so let's go ahead and get started. The first part that we're going to start discussing is single case experimental designs. Traditionally, we hear these referred to as single subject designs, and that's actually how I'm going to refer to it most of the time anyway. There are several different types of single subject designs, and these are actually used in the real world all the time. So, for example, people use this in applied behavior analysis, or ABA, as part of their jobs of behavioral interventions. A lot of times in education, we'll see this used with learning interventions to determine progress, especially within something called response to intervention, which is where schools will go through and test children on something, let's say, letter identification. And a lot of times what they'll do is they'll see how many letters a child can identify, not put them in order, right? But identify, like, this is a P and this is an E, how many they can identify in a minute. And then they will compare that to see if kids are functioning typically with those. And if they're not, then they'll develop interventions to help increase letter identification fluency, because we know that predicts later graduation rates. And so it's really interesting because they use these in schools all the time. So when we're doing single case experimental designs, we're always going to start with a baseline of where people's functioning is. So a lot of times this is a period where whatever behavior you're interested in observing, you just observe where it's at the beginning before you've done any type of intervention. Okay, so if we look here, there's different types of single subjects designs. There's a bunch of different ones, but there's a whole class of them called reversal designs. And these are basically where we demonstrate the reversibility of the manipulation. So if we put this into an actual example, there's something called an ABA design. This is where you collect baseline data. So if we look at this chart that we have, we see the baseline data where they have these different data points here. I think they have 6 data points before they start the treatment. Then they have 6 more data points where we see a steep increase in whatever skill that they're doing. So here, number of correct homework problems. And we see that the data points increase. And then we go back and we withdraw the treatment to see if then those behaviors decline now that the intervention's done. And so we see in this particular example that after they removed the treatment, that we're finding that the number of correct homework problems decreases. We also will see things called ABAB design, and that's where you do a baseline, then the treatment, the baseline, and the treatment, and you just see what the data does. You cannot actually use inferential statistics to analyze this type of data. So although it's a single subjects research design, you wouldn't be able to do any of the inferential statistics that you all learned in your stats courses, like your independent samples t-test or your dependent samples t-test or your ANOVA to analyze this data. Mostly, like if you're using this in the real world, you'll plot the data, you'll look at the trends in the data to determine if you believe that that treatment's effective. And a lot of times in the real world, they won't use an ABA design. They'll actually do the baseline treatment or the baseline, find where the behaviors are, and then watch the treatment. And then when they see the treatment, if it's going up, they'll look at trend lines to see if it's steeper than whatever goal line that you had set for the behavior or whatever you're trying to observe. There's also something called multiple baseline designs. And then so sometimes, like I was saying before, in the real world, you actually don't want to withdraw the treatment, especially if it's working. And so if you're using in the real world, you're not going to remove an intervention that seems to be working for a kid. You're just not going to do it. But sometimes what people will do, if they're doing it for research of some sort, is they'll do multiple baseline. And so the effectiveness of the treatment is demonstrated when a behavior changes only after the manipulation is introduced. To demonstrate the effectiveness of the treatment, such a change must be observed under multiple circumstances to rule out the possibility that other events were responsible. And there's 3 different types of ways that people tend to do this. We'll look for multiple baseline across subjects, across behaviors, and across situations. Most of the time, anytime that I've actually seen this used in real life, it's usually going to be this first one, looking at multiple baselines across subjects. So let's talk about this a little bit more. So if we have a small lowercase italicized n, that is the symbol for sample size, if you remember from stats. So if we have a small number of participants, but we have multiple participants, we can use this multiple baseline design to determine or to be able to see if we believe that the intervention is effective. So here in our little image, we find that we have 3 different participants. We take the baseline for everyone until their treatment begins, and we stagger when that treatment begins so that we can see if there's a decrease in this example, the number of cigarettes that someone smokes a day. So we see here, baseline for the first participants, once the treatment began, we see a significant decrease in the number of cigarettes that they are smoking. Participant 2 staggered out a little bit more. So instead of the 3 collection points, they have 6 collection points of data. Then we start the treatment, and when we see the significant decrease in the number of cigarettes that they've smoked. And then for our last participant, our third participant, we see that they took 9 data points of baseline, started the treatment, and then we see the decrease in the number of cigarettes. So if you're looking at this and you're trying to put this into real life, you're probably going to see that because we're seeing these changes in behavior after the introduction of treatment, and this is occurring across multiple subjects, that this might be an effective intervention for whatever clients that you're using. Now, if you're really trying to find cause and effect, we remember that we can only do that with a true experimental design, which this is not. So this is more of a practical type of research, but this is not a one where you can say, oh, this intervention absolutely does decrease the thing, because you can't do the statistical analyses to determine it because the sample size is too small. Replication. So repeating single subject studies with additional participants provides additional information on the effectiveness of the intervention or manipulation. And we really can't even say that an intervention is effective unless we've done a true experimental design. So again, we don't typically analyze data with statistics with this type of design, so replication becomes crucial. We also have quasi-experimental designs. And so when we cannot meet all the conditions of a true experimental design, we can use quasi-experimental designs just to analyze the data, but we cannot determine cause and effect with this. Again, you'll see it is bolded. It is capitalized. Cannot determine cause and effect from quasi-experimental designs. And people will use a whole host of words that still mean the same thing as cause and effect. So they'll say cause, effect, impact. These all insinuate that people are using a true experimental design. And so what we are examining with most quasi-experimental designs is to see if there's significant differences. Doesn't mean whatever our independent variable is caused these changes. We're just saying there's significant differences between the groups. So again, you have to use true experimental design to be able to determine cause and effect. So the different types of quasi-experimental designs that we're going to learn about: the one group post-test only design, the one group pre-test post-test design, the non-equivalent control group design, the non-equivalent control group pre-test post-test design, interrupted time series design, and a control series design. Okay, so these first 3, they can consider pre-experimental designs because they lack control groups, which makes it impossible for us to conduct inferential statistics with data, but it still can provide good information for us. So for example, if I wanted to get an idea how you all were doing in this class, I might find what the mean is of your midterm grades, or your midterm exam, or your final exam, or the mean score on some sort of final project. And those are descriptive statistics, but those are just means. And that's not something where we're able to examine the significant differences. We also have a one group pre-test post-test design. Many people just call this the pre-test, post-test design. And often I'll use this in a lot of my classes. And so when we do this, we use a within groups design where we have the same participants complete the pre-test before the manipulation, and the same group of participants complete the post-test after whatever your manipulation or intervention is. So for example, my stats students take a pre-test on the first day of class and a post-test on the last day of class. The reason why I do that is I use that as a piece of data to help me see or help me kind of evaluate my teaching. Okay. So although I use that as a piece of data, there are several threats to internal experimental validity when using this type of design, including history, maturation, testing, instrument decay, and regression toward the mean. And we covered some of this when we looked at internal validity, experimental internal validity. So history, if we remember, refers to any event that occurs between the first and second measurements, but it's not a part of the manipulation or the intervention. So history effects can be caused virtually by any confounding event that occurs at the same time as the intervention or the experimental manipulation that you have in your study. So because we don't have a control group to compare the intervention group to, we cannot be sure that the intervention caused those changes. So although it might give us data that these things changed between these points in time, we can't say with confidence that it's because of the intervention. All right, there's also the threat of maturation. Maturation effects are any changes that occur systematically over time. So for example, if we did a study on childhood asthma and we do a pre-test and we do a post-test, well, most children grow out of childhood asthma. And so it could be that they just got older rather than whatever treatment we did to try to cure it. Okay, so then we also have testing. Testing effects are when the pretest changes the behaviors of the study participants. So this was an example that was in your materials, but this actually is a real life one too. So literally tracking the number of cigarettes you smoke may actually reduce the number of cigarettes that you smoke. And it's not because of any intervention, but because you're actually keeping track and you're doing this pretest. And sometimes people want to beat those scores because they realize they probably don't want to be smoking that many cigarettes. We also have something called instrument decay. And instrument decay occurs when the basic characteristics of the measuring instrument change over time. So for example, when teachers grade a ton of papers, the rigor of how they grade often slightly shifts as they grade. So whenever I grade assignments, a lot of times I will remove the assignment from the view of the students so that I can grade through all of them. And then I calibrate my grading. So I keep notes because often teachers will get easier on the grading as they go through more and they get an idea, okay, I took off for this here, I took off for this here, and then trying to make them consistent. So if you don't go back and calibrate, that might actually be a problem with instrument decay. We also have something called regression toward the mean. And this is the tendency for extreme scores to move closer to the mean score the second time that they're tested. So this means that changes in behaviors could be due to this regression to the mean rather than real changes. And this often happens, and this is something we examine in my statistics class, but we've also learned about it this semester as well, that in any obtained score, so anytime that you collect data, so for example, your midterm that you took for me, if I collect that, you have that score, but that score might not actually reflect what you actually know about research methods. So the value that is truly reflective of what your ability is would be your true score. But in every obtained score, we have that true score, but we also have error in it. The book mentions measurement error. So just because we measure something, there's always going to be slight things off. There's no measure that's 100% perfect. So it could be, I wrote a bad question, so you got it wrong, right? It could be that you misinterpreted the question. It could be a whole host of things, but there's also measurement error. There's with inferential statistics, there's sampling error, and then there's also random error. So did you take your test in your freezing apartment and you're so worried maybe about being cold than actually your test? Did you take the test drunk, right? That's going to change your score. Did you stay up all night and cram? So error can be positive or negative. So sometimes maybe you guessed on an item and you got it right? That doesn't reflect your true ability. That's just a piece of error that's with it. And so because of that error, if you do really poorly on something the first time or really, really, really well, The second time, if you just retake it, usually it'll move closer to whatever that mean score is. So if we were in an in-person class, I like to do this example, and I don't know how well this would translate online, but I joke and I'm like, I'm going to do this mind reading test. Okay, so I'm going to have 10 questions that are true or false. And I want you to think and write down your answers. So you can try to do this. I don't know how to do this if I don't have a whole class doing it, but I'd be like, okay, y'all ready? 1. And you write your answer, right? Because it's mind reading test and seeing if you can read my mind. 2, 3, 4, 5, 6, 7, 8, 9, 10. So in class, you would have written down 1 through 10 and whether or not that I was thinking true or false, right? Because we're doing a mind reading test. And then I'd read off my answer. So the answer to 1 was true, 2 is true, 3 was false, 4 was false, 5 was true, 6 was true, 7 was false, 8 was false, 9 was true, and 10 was true. And then what we'd have the whole class do is say, okay, how many people got none right? Okay, how many got 1, 2, 3, 4, and we go through the whole number. And what we would do is I'd take the person with the lowest score. Let's say someone got 1 right and another person got 0. So I'd take those two people, like, let's do an intervention. And we joke, and I just make you do something outrageous, like spin in circles. We could play, I don't know. I don't even know what the hand clapping that we used to do as children. I don't remember what it's called. And we just joke, and I'd be like, okay, let's do this again. And then we do the mind reading test again. And I'm like, okay, the 2 that I put on intervention, let's joke, let's do this again. All right. And we say, all right, what am I thinking? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so those 2 people would do the mind reading test again. And then I'd say 1 is true, 2 is true, 3 is true, 4 is false, 5 is false, 6 is true, 7 is false, 8 is true, 9 is true, 10 is false. And then those 2 people would get their scores again. And almost always, actually, every time that I've done this in person, everyone's scores improved. Now, are you all really reading my mind? You're not. So what's going on here? What's happening is that people who do poorly the first time, just because they read it again, their scores regress toward the mean. Okay, and that because of the error that we have in every score that we have. So control groups, using control groups help with issues of history, maturation, testing, instrument decay, and regression to the mean. So there are quasi-experimental designs that utilize a control group, but these types of designs still do not allow you to make any statements about cause and effect. Okay, so for example, we have non-equivalent control group design. And in this design, this is where we examine significant differences between pre-existing groups. Okay, and so a problem with this is there might be some sort of selection bias or selection differences, and these usually occur when participants who form the 2 groups in an experiment are chosen from naturally existing groups. So, however, although this design says they're non-equivalent control group designs, if we haven't measured it, we actually don't know if they're equivalent or not. So I think that's kind of a little bit of a naming error with this type of design. A lot of times people will just refer to this as a quasi-experimental design instead of the non-equivalent control group design. There is another type of related design called the ex post facto design, or the after the effect design. And this is where participants are placed in groups based on some prior experience. So for example, sometimes students in this class want to study the effects of child abuse, right? So to do that, the effects of child abuse, we'd literally have to do a true experimental design. We'd have to have a sample of children. We'd have to randomly assign participants, the children in the group, to be abused or not abused during their life, and see if there's significant differences between the groups. What's the problem with that? Well, that is not ethical. We cannot abuse children. We can't do that. That's not okay. And so because it's not ethical, we use this ex post facto design instead, which means we just look at significant differences between people who are abused and not abused, but we cannot say that those things caused these other things to happen. Okay, so again, we cannot determine cause and effect from this type of design. We can only say there are significant differences between groups if they exist. So we also have non-equivalent control group pre-test, post-test design. So with this non-equivalent control group, pre-test, post-test design, we use pre-existing groups, but conducts pre-test and post-test with both of the groups. So honestly, this is kind of good because we can actually determine if groups are equivalent on the dependent variable at the very beginning of the study. And if they're not, we can also look at changes between the pre-test and post-test scores for both groups to see if there's any changes. There's a more advanced technique called propensity score matching. And this is actually pretty cool. I've not gotten to use it yet. But instead of trying to do like a match group design that you learned about in your statistics class, we can actually measure participants in each of the groups on multiple variables and then compare the difference on the dependent variable between two participants that are similar on those other variables from each group. So we also have an interrupted time series design. And this examines changes in behavior over a long time period, both well before and after the intervention. Okay, so for example, if we want to examine if there were significant decreases in fatal accidents after the implementation of Missouri's no cell phone on the body while driving law, we could go through and examine for 10 years prior to this change that happened in August, what the fatalities were from car accidents in Missouri. And actually MoDOT does collect that information every year. And then after, like, we would collect data for fatalities in Missouri for the next 10 years after, or however long after, and compare to see if there's a significant difference. There's also a control series design, which is much like that interrupted time series design, but it uses a non-equivalent control group to compare the differences. So for example, if we want to examine this Missouri, you can't have your cell phone not just in your hand, you can't have it on your lap anymore, if y'all didn't know, since August. If you have that in Missouri, we could also get another state that doesn't have that kind of law, and we would collect the same data points on the number of fatalities each year or the percentage of fatalities each year in each state and see if there's a significant difference. So if we look at the little image that we have on this slide, we see that we have one, which is our intervention group, which is in blue, and then the non-equivalent control group in black. And although we're not doing any inferential statistics with this image, we can see that there's a difference between the state with it and without. So we also have some developmental research designs. The three most common are cross-sectional method, longitudinal method, and sequential method. So cross-sectional method in developmental research is where we study people of different ages exact same time. So for example, if we want to examine the differences in the amount of sleep that high school students got across the grade levels, we could go into one high school and get the average amount of sleep of all 9th, 10th, 11th, and 12th graders, and then see if there's significant differences among those four groups. So the problem with the cross-sectional method includes something called cohort effects. And in order to understand cohort effects, we need to discuss the word cohort. So cohorts are basically people who travel through time together. If we're talking about birth cohorts, these are people that were born at the same time as you. If we're talking about graduate school, your cohort are the people that you go into school with at the same time. Okay, so cohort effects occur with the cross-sectional design when the differences that we examine in our dependent variable are due to the differences between cohorts, not actually differences in the dependent variable. So, for example, when they were examining differences between people who belong to other generations and millennials, so I'm a millennial, but when they did that, they found that millennials actually have higher connections to the family than other generations do. So if we were doing some sort of study where we're looking at familial closeness or something like this, cross-sectional method would be really difficult to use because there's just differences in how my generation relates to their families in comparison to other generations. So we also have a longitudinal method, and this is when the same group of people are observed at different points in time as they grow older. This is one of the really common types of things that we'll see in developmental research. And I don't know if y'all have seen it, but there is a documentary called Seven Up, and they got children from, I believe it was Great Britain, and at age 7, they interviewed them. And then at age 14, 21, 28, 35, 42, all the way up, and I don't remember if 56 Up was last one or 62 Up, but the director of that movie passed away, unfortunately. So I don't know what the series is doing now. But that's kind of a longitudinal research design. We're catching the same participants across their lifespan as they age. If we're thinking about this with relation to studies where you can use inferential statistics, this is where you're using kind of within group design, or repeated measures design is what they'll also call that. And you're just testing the same participants over and over again. We also have a sequential method, and this is where we combine both cross-sectional and longitudinal designs to balance out the drawbacks and strengths of each. So for example, longitudinal, it's great because we don't see the cohort effects necessarily within the particular study, but longitudinal studies are very expensive. They take a lot of time, and we can see that kind of some cohort effects, I guess, with it too, because if we're tracking millennials, whatever we see with millennials may not go with other generations, right? Generation X, or baby boomers, or Generation Y, or Generation Z, and these different things, or Generation Alpha. And so when we're doing that, when you're using sequential method, it's kind of nice because you have a pinpoint right at one time of what we're seeing significant differences between whatever the 4 groups that you're doing at one time, but then you also follow them to see if some of these differences are due to the generation or the age or the cohort instead. So that's what I have for you this week. Hopefully you enjoyed this lecture, and I'll see y'all soon.